Verifying trig identities, Chapter 5, Lesson 2. In Lesson 1, we had discussed the 3 Pythagorean identities and the 2 quotient identities. These need to be memorized for you to be successful throughout this chapter. So please work on that. I do have them on Quizlet. You need to start doing 10 question Quizlet every day when you walk into class, and also 10 every night when you log in to do your homework. The cotangent of x times the sine of x times the secant of x. The directions tell you to rewrite this with just sines and cosines, then simplify the expression so that no quotients appear in the final answer. So to do that, if we remember just a minute ago, we had just said that the cotangent of x was the cosine over the sine. So that's how you want to rewrite the cotangent. The secant of x equals 1 over the cosine of x. That's something old that we've done before. So if you take this numerator here of cosine x will reduce with this cosine. This sine will reduce with that sine. After each one reduces, you'll have the answer of 1. So cotangent squared plus tangent squared times the quantity of tangent squared plus 1. Again, the direction said rewrite it with sines and cosines first. So cotangent is cosine over sine, and then those will each be squared since this was cotangent squared. You have tangent squared. Tangent is the same thing as sine over cosine, so that tangent is squared, so each of these will be squared as well. Now we're going to distribute. We are going to take this fraction that's on the outside, and we are going to times it by this fraction here, and then we're going to multiply it by 1. We're going to distribute. So that fraction times the fraction on the inside, actually in that case would give me 1. Then cosine squared over sine squared times 1 would be cosine squared over sine squared. Now from here, we know cosine over sine would happen to be equal to cotangent. And since those are both squared, this would be a cotangent squared. Now, if you think back to your Pythagorean identities, anytime you see a 1 and you see these squared, the first place you want to look would be your Pythagorean identities. So I'm looking for 1 plus cotangent squared. Notice 1 plus cotangent squared equals cosecant squared. So that would be the answer. Now, personally, I would not have done it this way. I would have noticed that that says tangent squared plus 1. Tangent squared plus 1 off of my sheet here, tangent squared plus 1 would actually be equal to secant squared. So I actually would have started off with rewriting what was in the parentheses as one of my Pythagorean identities. Now I would have rewritten the cotangent, sorry about that, the cotangent as the cosine over sine, and the secant 1 over cosine squared. These cosine squareds would reduce, therefore I would get 1 over sine squared, and then when you bring that back up, you go right back to the answer of cosecant squared. So again, personal preference there. If I ever notice the Pythagorean identities, I go ahead and simplify those first with the identity. Then I proceed back to the directions. I rewrite it with sines and cosines, simplify, and then no quotients may appear in the answer. Now this time I don't have an identity right off the bat. I do have a binomial square though, 9 plus the sine of t. So 9 plus the sine of t, if some of you use FOIL or if some of you use boxes, you would go ahead and put 9 plus sine t times 9 plus sine t. Some of you have learned to square a binomial without foiling or boxes, and doing that, that was 9 squared, there's the 81. You multiply the 2, that'd be 9 sine t, doubled, that's the 18 sine of t. This term squared, that's where the sine squared of t comes from, and then we just rewrote the cosine squared. This is a Pythagorean identity. Hope you're starting to realize that sine squared plus cosine squared equals cosine squared plus sine squared is 1. So that right there became 1, and 1 plus 81 would be 82 plus 18 sine of t. We are supposed to factor each expression. This is sine squared minus 25 cosine squared of t. If we think back to Algebra 1 when we had a difference of squares, a squared minus b squared, that factors to a minus b and a plus b. Notice there's the minus sign. The a would be equal to sine of t. My b is going to be 5 times the cosine of t. Because see, 5 cosine t times 5 cosine t would be 25 cosine squared. So you literally just substitute in for each one of those. So again, that A was the sine of t, the B was 5 cosine of t, and we're just plugging into our difference of squares. All right, when we need to factor the next one, I hope you guys remember in your U substitution from college algebra and algebra 2. My U here would equal the tangent of y. So therefore, when I go to factor, I'm actually going to have 2u squared plus 15u plus 28. Most of you in here do the x factor. Some of you will do factoring with boxes. Some of you do trial and error till you get the factor. That'll be a personal choice, whichever way you choose. For those of you who do the x, that was we took the first times the last, so that was 56. The middle term was 15. And don't forget that you want to put them over the first coefficient, and that first coefficient was 2. So the factors of 56 with the sum of 15 was 8 and 7. Now the 8 over 2 reduces to plus 4. So my factor is going to be u plus 4, 2u plus 7. Now u was the tangent of y. So we plug tangent of y back in for each of the u's, and we'll have our final answer. Write as a single trig function or a power of a single trig function. All right, well, we know tangent is the same thing as sine over cosine. Cotangent is cosine over sine. So just reminding you real quick, that's coming from your quotient identities. The tangent is sine over cosine. The cotangent is cosine over sine. Now dividing fractions easy as pie. We want to flip this one, the bottom, to multiply. Now when I'm looking at that, I notice that would give me sine squared on the top. It'll give me a cosine squared on the bottom. Sine over cosine is equivalent to tangent, so this answer would be tangent squared of x. Now some of you might have noticed from the very beginning, what if I had just written the cotangent straight up immediately? See, if I take the reciprocal of cotangent, that would be tangent. So that would be bringing that up. That would end up with tangent of x times tangent of x, which again is right back to tangent squared. All right, on this next one, I have sine squared over cosine squared plus the sine times the cosecant. Now cosecant's the reciprocal of sine. So I said, okay, I took care of that. Now sine over sine is 1. Sine squared over cosine squared happens to be sine over cosine. Don't forget on the quotients. Sine over cosine is tangent. See, this would lead to tangent squared plus 1. If you have tangent squared plus 1, take a look at your Pythagorean identities again. Tangent squared plus 1 is secant squared. And that answer is then secant squared. A single trig function. In other words, I can't have, when the directions say write as a single trig function, that's meaning I can't have like the word tangent and cotangent. I can't have sine and cosine in there and the cosecant. I can only have one of the trig function names written down. Okay, this question is similar to question number 16 in your homework. You might end up at the end of this example pausing your notes. Go ahead and open up 16 on lesson 5.2 and follow along with it. All right, we're going to verify tangent squared over secant squared of s equals the sine squared of s. So first off, we're going to start with that left side. The tangent we know is sine over cosine, and we know the secant is 1 over cosine. The tangent is sine over cosine. That is our quotient identity. The secant, the reciprocal, is 1 over cosecant squared, so it's reciprocal. That'll be your step 1 on that homework question, something similar to this. Now we know dividing fractions easy as pie. We're going to flip this second one here to multiply. Normally we reduce at this point, but your homework system is asking you for the unsimplified numerator and denominator for this question. So the unsimplified numerator and denominator means do not just reduce the cosine squared immediately. They want you to actually write it like this in the computer system. Sine squared times cosine squared, both of them are of s, sorry. And the denominator times 1, so therefore cosecant cosine squared of s. So that is actually your step 2, the unsimplified numerator and denominator. Now we'll do our reducing, and then we'll have our final answer. So again, step 1 will be to use your quotient and reciprocal identities. Step 2, they want the unsimplified numerator denominator, like this, before you reduce this off. And then step 3 is going to be what's the final answer. That was all of your notes for lesson 5.2. I hope this was helpful. Try to do at least the multiples of 4 before you come to class. Thank you very much. Have a great day, y'all.